Perpendicular and angle bisector is our topic for today. First, perpendicular lines are two lines intersecting each other at 90-degree or right angle. For the angle bisector, it is a line that split or divide the angle into two equal angles. So the perpendicular bisector theorem, it states that if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. As we see in triangle AXB, XY is perpendicular and bisects AB, so X will be equidistant from A and B, the endpoints. So XA will be congruent to XB, which means the perpendicular bisector theorem. A triangle tells us that if a sides of a triangle intersects at a point called the circumcenter, then the segments created from the vertices to the circumcenter of the triangle are equidistant, or we can say equals. Let's have an example to clarify this. As we see in the first example here, MNL triangle, NP is perpendicular and bisects ML. NL is 2.6. We want to find MN. So we're going to the theorem. NL will be congruent to NM. So NM will be 2.6 as well. Another example. As we see in triangle ABC here, we want to find BC, the length of BC. Since AB equals AC and L perpendicular to BC, which is the perpendicular bisector of BC, by the converse of the perpendicular bisector theorem, so BC equals 2CD, which is twice the 12, which is 24.
Stay focused.
Let's have more examples to master the skill. As we see in triangle TUV here, UW is perpendicular and bisects TV. So with respect to the theorem, UV will be congruent to UT or equals UT. So let's equate 3x plus 9 equals 7x minus 17. Simplify and solve the equation. So 9 equals 4x minus 17. Add 17 to each side. So for 26 will be equal 4x divided by 4. So x will be 6.5. Now replace x in TU. So it will be 28.5. Let's move to the second part of the lesson, which is distance and the angle bisector. As we see in the angle APB here, PC is the angle bisector. So we can say that CA equals to CB. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. The converse for the theorem, APP, the angle, we can say CA here equals to CB. So PC will be bisector for the angle. If a point in the interior of an angle is equidistant from the sides of the angle, then it is the bisector of the angle. Let's solve an example. Find the measure of angle EFH, given that measure angle EFG is 50 degree. Since EH equals GH, and EH is perpendicular to FE, and GH perpendicular to FG, FH ray bisects the angle EFG, so by the converse of the angle bisector theorem, measure angle EFH will equal half the measure of angle EFG. Since this one is 50, so half the 50 would be 25. Very easy. Let's relate this question to the real life. S is equidistant from each pair of suspension lines. What can you conclude about QS? QS ray, we can say it bisects angle PQR. So today we had distance and perpendicular bisector, distance and angle bisector, and questions.